Let's move on to moment of force. Moment of force. What is moment of force? That is process of rotating an object using an unbalanced force. Using unbalanced force around particular axis. So in order to find moment of force, what you have to do is take the force, it should be multiplied by the perpendicular distance. So instead of moment, m can be used, which is equal to F into d. F is the force, d that is important perpendicular distance. So you can take the unit as Newton meters and the dimension ml square t minus 2. ml square t minus 2. Now we can consider the direction of the moment. So in order to get the direction, actually what you have to do is, we know that due to this force, due to the presence of this force, object rotates towards anti-clockwise direction. So then, in order to get the exact direction of the moment, use your right hand and the four fingers without the thumb should be towards the rotating direction. The direction of the thumb gives you the direction of the moment. So that is away from the board. Okay? Now we can find the algebraic sum of moment around particular axis. That particular axis goes through O. This is D2. Main important thing is F3 goes through point O. Then we can consider F4 as well. So the perpendicular distance is D4. Then what you have to do is consider the moment around O. Starting from, let's take the clockwise direction as positive, which means moment around O towards clockwise direction is positive. F1 into D1, that is, what would be the direction? This should be clockwise. So that is plus, considering F2, what happens? This is the force, this is the perpendicular distance, then this is the direction of the rotating, due to this force. So F2 into D2, but the thing is that rotates towards anti-clockwise direction. Therefore, it is getting negative. What happens to F3? No moment given by F3 because which goes through point O. Then what happens considering F4 into D4, that is towards anti-clockwise direction, again negative. This is way of finding algebraic sum of moment around particular axis. Let's move on to example. This is ABCD rectangle plate. So you are given AB. AB is 4 meters and BC is 3 meters. This is 2 newtons, 3 newtons, 5 newtons, 4 newtons, this is 5 newtons and 10 newtons. You can take this angle as alpha each. It could not be 45. Now we can find moment around A towards clockwise direction. So in order to find moment given by these forces, first of all you have to identify the forces which go through point A. So there are three forces. Three forces go through point A, such as 4 newtons, 5 newtons and 2 newtons. So those forces do not give any moment around A because there is no perpendicular direction from point A. Let's consider the other forces like 5 newtons. What would be the perpendicular distance? This is the line of action of 5 newtons. The perpendicular distance should be AD. AD, which is equal to BC. So that is 3. That is 3. So then it is clockwise direction. It should be positive. Then we can consider these 3 newtons. What happens there? The perpendicular distance from point A is AB, which is equal to 4. But the thing is, the direction is anti-clockwise direction. That is negative. What else to be considered? The 10 newtons. So get the component of 10 newtons along BA and BC. Taking the component of 10 along BA, that is towards angle 10 cos alpha, considering this, that is 10 sin alpha. So what would be the considered one? It should be 10 sin alpha because 10 cos alpha goes through point A. So 10 sin alpha is the force. The perpendicular distance yet to be considered. So 10 sin alpha is the force. The perpendicular distance should be AB. AB is 4. So what happens to the direction? Again anti-clockwise direction. Therefore this is B negative. Then we can consider sin alpha and cos alpha. Okay, so how would you find sin alpha? That is opposite over hypotenuse. So opposite, that is given as 3 divided by 5 is sin alpha. Cos alpha, so adjacent divided by hypotenuse, so 4 divided by 5. So no need to consider tan alpha. Now this is plus 15 minus 12. What happens here? If sin alpha equals 3 divided by 5, that is 12 minus 24 minus 36 minus 36 minus 15 minus 21 Newton meters. Minus 21 Newton meters. Likewise, you can find MA, MB, MC, MD and MO. This is the way of finding moment around given point. Now we can find the line of action of resultant. Line of action of resultant. So using a particular example we can complete. So you are given a square type metal sheet. So then This is A, B, C, D. You are given this is 3 newtons and 3 root 2 4 root 2 and this is 1. Considering this direction, let's consider the resultant of given forces. How would you find the resultant? Here you can take the angles are 45 each. So according to the given sum, what you have to find is magnitude of the resultant, line of action of resultant. So here you have to get the component along x-axis as well as y-axis, then get r square equals x square plus y square. So considering this direction, 3 Newton can be considered because we are considering positive direction of x-axis as plus. So this is again plus. Here you have to take the component 3 root 2 cos 45. That is positive. Then consider 4 root 2 again cos 45, but it should be negative. So what happens here? Cos 45 root 2 cut, cos 45 root 2 cut. So this is plus 4 and minus 4 cut. The remainder is 3 newtons. Now we can consider the components along y-axis. This is plus 2 and this is minus 5. Consider the component of 4 root 2, that is sine 45. It should be plus. Considering 3 root 2 sine 45, again positive. So what happens here? So root 2 45 sine 45 cut. So altogether 7, then 9 minus 5, 4 newtons. 4 newtons. So then in order to get the resultant, you can make use r square equals x square plus y square. This is 3 newtons away from each other, 4 newtons. The diagonal gives you the resultant r square equals 4 square plus 3 square. So r equals 5 newtons and the angle, that is tan alpha, 4 over 3, which means 53 degrees approximately. Now we can find line of action of resultant. What is meant by line of action of resultant? So we know that the resultant is 5 newtons and the angle is 53 respective to AB direction towards anti-clockwise direction. That's okay. But the thing is, we don't know the exact point, the line goes through in between AB or away from AB, we don't know. So now we have to find the magnitude of the line of action. So this is 4 newtons and this is 3 newtons. Actually no need to take the 5 newtons which is resultant. Take the component of 3 newtons and 4 newtons. The important thing is you have to consider this magnitude as x. that is has to be found. That has to be found using the theory just like this. So what you have to do is take the moment around point A of given forces should be equal to the moment given by the resultant. So what you have to do, take moment given by forces around point A. So considering these forces which gives you zero moment. So this is one, take AB as 2 meters. So 1 into 2. 2 is the perpendicular distance, unlike this 2 newtons. Then it should be clockwise, which means it is positive. Then considering 5 newtons, what happens? 5 into again 2 meters. That is again clockwise. So now we have to consider this 4 root 2. Take the component of 4 root 2, that is 4 root 2 sine 45. That is the considered component, unlike 4 root 2 cos 45. So considering that 4 root 2 sine 45, it should be multiplied by 2 again clockwise, which can be equated to the moment given by the resultant. So resultant, the magnitude of the resultant is 5, that's okay, but the thing is, it's better to consider the components along x and y direction. The main important thing is no need to consider 3 newtons, which is along AB. So the one and only force to be considered is 4 into x gives you the moment, but make sure the direction is anti-clockwise, so this is negative. So what happens here? This is 2, 10, 12 and this is 8, altogether 20. 20 equals minus 4x, x equals minus 5 meters, which means the line of action of the resultant goes through the extended BA side. Unlike AB, extended BA side. Okay, the angle is 53. We know the exact point which goes through the extended BA line. That's all. Now we can consider two parallel forces. We can find the line of action of the resultant of those two forces. Capital A, the given forces when forces are same direction, which means this is F1, this is F2. If F1 is greater than F2, the resultant should be F1 plus F2. We know that. This is the line of action of resultant. If you take, this is simple A and simple B, then what you have to do is take moment around point O. We can use that theorem. What's that theorem? The moment given by other forces should be equal to the moment given by the resultant. So considering F1, the perpendicular distance is A, that is clockwise, which means it is positive. Considering F2, perpendicular direction is B, that is anti-clockwise direction, which means negative. Now you have to consider the resultant like F1 plus F2, but unfortunately it goes through point O, which means no perpendicular direction. So ultimately F1 into A equals F2 into B, which means F1 divided by F2 equals B divided by A. B divided by A. Actually that can be F1 divided by F2 equals the perpendicular distance involving with F2 divided by perpendicular distance involving with F1, which is the other way around. F1 divided by F2 equals B divided by A. Okay. So for example, if F1 is given as 9 newtons, F2 given as 27 newtons, so if the perpendicular distance as 40 centimeters, you can find simple A just like this. F1 instead of F1 9, instead of F2 27, it should be divided by B divided by A. Okay, if you are looking for finding A, what you have to do is instead of B, 40 minus A can be substitute, divide by A, which is B divided by A. So what happens? This is 1, this is 3. Take the cross multiplication, 120 minus 3A, 4A equals 120, A equals 30 centimeters. That's all, which means B equals 10 centimeters. B equals 10 centimeters. So I use the same figure. The resultant should be towards the force which is greatest. Okay. Let's move on to the other part. Forces. When forces are opposite direction. So this is F1, this is F2. F1, let's take F1 is greater than F2. So what happens to the resultant, which is F1 minus F2? And the main important thing is which is away from F1 and F2. This is F1 minus F2. Then what you have to do is take the perpendicular distance from point O to F1 as B, and this is simple. This is simple B, this is simple A. Then the same procedure, which means take the moment around particular point of given forces should be equal to the moment given by the resultant. So taking MO towards clockwise direction as positive. So what happens? F1 into A, that is anti-clockwise direction, negative. F2 into B, that is positive, which is equal to 0. Why? Because the resultant goes through point O. So the same procedure, F1A equals F2 into B, which means F1 divided by F2 equals B divided by A. Right. For example, if you are given F1 as 40 newtons and F2 as 10 newtons, and this is 60 centimeters. How would you find simple A? So using the same procedure, F1 is 40, F2 is 10, B. So instead of B, we can take A plus 60 divide by A. So 4A equals A plus 60, which means 3A equals 60, A equals 20 centimeters. Now we can move on to moment, the special type of moment which is called couple of force. Couple of force. So that occurs according to the previous theory when equal forces, when forces are opposite in direction, but the magnitude is equal. What happens here? No resultant, which means resultant is 0, but the thing is there is a moment. There is a moment that is called torque. So that can be found using FD, which means magnitude of 1 should be multiplied by the perpendicular direction, perpendicular distance in between two forces. So the main important thing is when considering couple of force around any point, what happens? The magnitude is equal as well as the direction. That is the characteristic of couple of force. Now we can move on to center of gravity. Center of gravity. What is center of gravity? An object contains point masses. We know that object contains point masses. When that object inside the gravity, the force, the parallel force is given by the gravity, on each and every point masses. So as a result of that, the resultant line of action of resultant of all these forces goes through a particular point which is known as center of gravity. What are the features of center of gravity? First one, it could be on the object or away from the object. What would be the example? Considering a circular plate, the center of gravity at the center, we know that is on the material. But when considering a ring, what happens? Center of gravity is at the center, but the thing is that is not on the material where occupies. Okay. The second one. What could be the second one? The second one, when object is hung by a particular point, and if you create the vertical axis goes through that particular point, center of gravity should be along that particular point. For example, this is non-symmetric object which is hung by point A, and using a marker pen we are marking the vertical axis, so we can conclude the center of gravity should be in between or along AB direction. Actually, that theory can be used in order to find center of gravity of one symmetric or non-symmetric object. How is that? That is, we know that, let's consider the same object. We know that the center of gravity of this object along AB. Then, actually this is according to the first experiment. Right. Now we can consider other point like C. Then this is the vertical axis. This can be taken as D. So this is the vertical axis according to the second experiment. What happens? The intersecting point gives you the point where center of gravity locates. That is the way of finding center of gravity, which means capital G, a given object, which could be symmetric or non-symmetric. Okay, let's move on to the third one. So if additional mass is added, what happens? The center of gravity of the object moves towards that direction. The opposite of that procedure, when a mass is removed from the object, what happens? The center of gravity goes away from that light area. That is the third one. Then the fourth one is the center of gravity doesn't depend on where it locates. Those are the main features of center of gravity. So addition of that, we can consider a symmetric object. The center of gravity of the symmetric object should be on axis of symmetric. Okay, so now we can consider the location of center of gravity of uniform objects. The very first one should be a uniform rod. The center of gravity should be at center. The second one, what would be? So you can consider rectangular plate, square type, rhombic one, a kind of a rhombus, and parallelogram. What happens? The center of gravity locates the coinciding, the intersecting point of diagonals. Let's move on to the third one. As we considered the previous, you can consider a circular plate. The circular plate, the center of gravity is at the center. Considering ring, what happens considering ring? Again center. Now you can consider a spherical shell, again center, and this is solid sphere, again center. This is circular plate, ring, spherical shell, and this is solid sphere. Let's consider the fourth one. That is a rectangle plate. So the center of gravity should be 2:1 from this point, which means if you are given the height as simple edge, this OG can be found as h divided by 3 because the ratio is 2:1. Now we can consider the fifth one, which is spherical cone and solid cone. So what happens there? So considering spherical cone, OG should be 2:1, same as the rectangular plate, triangular plate. This is h divided by 3, so this is 3:1. This is G, this is O, OG equals h divided by 4. H divided by 4. Now we can move on to finding the center of gravity of combination, which consists two symmetric objects. For example, you are given square type square type sheet and rectangular sheet. So this height is 3a. So first of all, you have to mark the symmetric line, because if there is a symmetric line, center of gravity should be along that particular axis. So first of all, you have to consider the square type one. So you can take the weight as m1g, and this should be a divided by 2, half of simple a. Then you have to consider the rectangular plate. The weight should be m2g. So we can consider g1, the gap between g1 and g2 should be a divided by 2 plus 3a into 1/3, which is 3a divided by 2. That is the gap between g1 and g2. So we know that when two parallel forces with same magnitude, with same direction, we can find the resultant. The line of action of resultant should be in between given forces, just like this. You can take this distance as x. This distance 3a divided by 2 minus x. So now we can consider f1 divided by f2 equals b divided by A. So F1 you can take M1G, F2 M2G, B that is 3A divided by 2 minus X divided by X. GG card. When finding M1 and M2, take the area. What is the reason? The area of the sheet is directly proportional to the mass. So area of the square type sheet is A square, and M2 half into base into height. Base is A, height is 3A. This is 3A divided by 2 minus X divided by X. So A square cancel off. Then what happens? 2 goes up. So then cross multiplication, 2X equals 9A divided by 2 minus 3X. So altogether 5X. So X equals 9A divided by 10. This is the way of finding X. Let's move on to other example, which means a circular sheet of radius 10 centimeters is removed from the circular sheet of radius 20 centimeters. So this is the remaining object. So here there is a symmetric axis there. So the center of gravity of the remainder should be along the center of, along the axis. You are given circular plate of radius 20 centimeters, then another circular plate of radius 10 centimeters is removed. As a result of that, the center of gravity of the remainder goes towards left respective to the center, because here there is a white place now, which means a light area. So the center of gravity should be away from the light region. So you can take that point as G1, that weight is M1G, this distance what we are looking for. Then the removed one can be considered. It is like M2G, the radius is 10 centimeters. Now what you have to do is, this removed one should be pasted again. And then what happens? Again we can see a circular plate of radius 20 centimeters. You can take this point as G2. This is M2G. We know this distance as 10 centimeters. So now F1 divided by F2 equals B divided by A. M1G divided by M2G equals 10 divided by X, unlike X divided by 10. What is M1? M1, we can take the mass is directly proportional to the area. So area pi 20 square minus 10 square divided by M2, that is the removed one, 5 10 square. So what happens here? Pi cut. This is 400 minus 100, 300 divided by 103. X equals 10 divided by 3, which means 3.33 centimeters. So we can conclude this is M1 plus M2. we can conclude the x value is 3.33 centimeters. Now we can consider as finding the center of mass of point masses. So you are given m, 2m, this is like 9m, then 48m. So what you have to find is the center of gravity of these systems. So first of all, you have to join these two masses. This is like F1 mg, this is like F2 2 mg. So the resultant should be 3m or 3 mg. And what would be these ratios? This is 1, this is 2, so 2 is to 1. Now you can consider 3m and 9m. What happens altogether? 12m's, 12m, this is 1, this is 3, so this ratio is 1, this ratio is 3. Now you have to consider 12m and 48m, altogether 60m. So what would be the ratio? This is 1, this is 4. So this is 4, this is 1. So this is the center of gravity of the system. Okay, when finding the center of gravity, the addition of all masses should be equal to the final mass. Otherwise, you have to consider the remaining mass as well. This is the way of finding center of gravity of given masses.